Download this code from codegive.com, link in the description below. OK, let's dive into response validation. This is a crucial aspect of building robust and reliable APIs, web services, or any application that interacts with external services over a network. This tutorial will cover the concepts, benefits, techniques, and provide practical Python code examples to illustrate how to implement response validation effectively. What is response validation? Response validation is the process of verifying that the response received from an API, or any external service, conforms to the expected structure, data types, and values. It ensures that the data you're receiving is valid and can be safely processed by your application. In other words, you're making sure that what you expected to get is what you actually got. Why is response validation important? Error prevention. Validating responses proactively catches issues early, preventing them from propagating further into your system and potentially causing unexpected behavior, crashes, or data corruption. Data integrity. Ensures that the data your application uses is accurate and reliable. Incorrect data can lead to incorrect calculations, decisions, or display issues. API contract enforcement. Validates that the API you're using is adhering to its documented contract, the API documentation, giving you confidence that the service provider isn't introducing breaking changes without notice. Improved debugging. When validation fails, it gives you a precise indication of what's wrong with the response, making debugging and troubleshooting much easier. Instead of tracing through complex code to find the root cause, you can pinpoint the exact field or data that's invalid. Defensive programming. Makes your application more resilient to errors and unexpected situations. It helps you handle cases where the API response is incomplete, malformed, or contains incorrect data. Security. Helps to protect against certain types of attacks, such as data injection or manipulation attempts, by ensuring that the data you're receiving is what you expect. Key aspects of response validation. 1. Schema definition. Defines the expected structure, data types, and constraints of the response. This can be done using various schema languages or libraries. 2. Validation engine/library. A tool or library that implements the validation logic. It takes the response data and the schema as input and determines whether the response is valid. 3. Error handling. Defines how to handle validation failures. This might involve logging errors, raising exceptions, returning error messages to the client, or implementing fallback mechanisms. Methods and tools for response validation. Python examples. Let's explore some common Python tools and approaches for response validation, along with code examples. 1. Using JSON schema library. JSON schema is a popular Python library for validating JSON data against a JSON schema. Installation. Example. Explanation. JSON schema. The schema variable defines the expected structure of the JSON response. It specifies the data types, type, for each field and marks user ID, title, and completed as required. Validate function. This function from the JSON schema library takes the response data, response_data, and the schema as input. Error handling. The try, except block handles potential validation error exceptions, which are raised if the response data doesn't conform to the schema. The except block will also catch any other exceptions that may occur. The exception contains detailed information about the validation failure, including the field that's invalid and the reason for the error. 2. Using Pedantic. Pedantic is a powerful library for data validation and parsing. It uses Python type hints to define the data structure and automatically validates the data. It's particularly well suited for building APIs and data models. Asterisk installation asterisk. Asterisk example asterisk. Explanation asterisk. Asterisk pedantic model asterisk. The Toto class defines the data structure using Python type hints, example user ID, int, title, str. Pedantic automatically generates validation logic based on these type hints. Asterisk validation asterisk Toto, response underscore data, attempts to create a Toto object from the response underscore data. If the data doesn't match the model's definition, example incorrect data types, missing required fields, Pedantic raises a validation error. Asterisk error handling asterisk. The try, except block catches the validation error and prints the error details. The validation error object contains information about each validation error, including the field that failed validation and the reason for the failure. Asterisk optional fields asterisk. The optional str type hint indicates that the phone field in the user model is optional. If it's missing from the input data, Pedantic will assign the default value, which is none in this case. 3. Manual validation, less recommended for complex scenarios. You can also perform validation manually, especially for simple cases, but it's generally not recommended for complex data structures or when you need to enforce strict constraints. Explanation asterisk. Asterisk. The validate underscore response function checks the data type of the response, verifies that all required fields are present, and then checks the data types of each individual field. Asterisk. It returns a tuple indicating whether the response is valid and an error message if it's invalid. 4. Integrating response validation with API requests, using requests library. This example demonstrates how to integrate response validation with API requests using the requests library. Explanation asterisk. 1. Get underscore an underscore validate underscore data, URL, schema, function asterisk. Asterisk takes the API URL and JSON schema as input. Asterisk uses the requests library to make an HTTP GET request to the API. Asterisk response.raise underscore for underscore status, checks if the HTTP status code is in the 200 to 299 range, success. If not, it raises an HTTP error. Asterisk response.json, parses the JSON response. Asterisk validate, instance equals data, schema equals schema, validates the parsed JSON data against the provided schema. Asterisk handles potential exceptions. Asterisk requests.exceptions.request exception, for network-related errors, example connection refused, timeout. Asterisk JSON.JSON decode error, if the response is not valid JSON. Asterisk validation error, if the JSON data doesn't match the schema. Asterisk returns the validated data if successful, otherwise, returns none. 2. Error handling asterisk. The try, except block catches different types of exceptions that can occur during the API request and validation process. This allows you to handle errors gracefully and provide informative error messages. 3. Example usage asterisk. Asterisk. The API underscore URL variable holds the URL of the API endpoint. Asterisk. The get underscore an underscore validate underscore data function is called with the URL and schema. Asterisk. If the function returns data, i.e., the response was valid, the data is printed. Otherwise, an error message is printed. Best practices for response validation asterisk. Asterisk. Define clear schemas asterisk. Use a schema language, JSON schema, YAML schema, etc., or library, pedantic, to clearly define the expected structure, data types, and constraints of your API responses. Validate early. Perform validation as soon as you receive the response from the API. This prevents invalid data from propagating through your system. Provide informative error messages. When validation fails, provide detailed error messages that indicate which field is invalid and the reason for the failure. This will help with debugging and troubleshooting. Log validation errors. Log validation errors so you can track and analyze the frequency and types of errors that are occurring. This can help you identify issues with the API or with your validation logic. Consider API versioning. When an API changes its response structure, use API versioning to ensure that your application continues to work correctly with older versions of the API. You might need different validation schemas for different versions. Test your validation logic. Write unit tests to verify that your validation logic is working correctly. Test with both valid and invalid data to ensure that your validation rules are being enforced as expected. Document your schemas. Include the schema definition in your API documentation so that consumers of your API know what to expect in the response. Choose the right tool. Select the appropriate validation tool or library based on the complexity of your data and your specific requirements. For simple validation, you might use manual validation. For more complex data structures, JSON schema or pedantic are better choices. Handle optional fields gracefully. When dealing with optional fields, make sure that your validation logic can handle cases where the field is present or absent. Use optional type hints in pedantic or adjust your JSON schema accordingly. Be strict but flexible. Be strict in enforcing your validation rules, but also be flexible enough to handle minor variations in the response data. For example, you might allow extra fields in the response, as long as the required fields are present. Consider performance. Validation can add overhead to your application. Choose validation techniques that are efficient and minimize the impact on performance. For example, consider caching validation results or using optimized validation libraries. Avoid reinventing the wheel. Use existing validation libraries and frameworks whenever possible. These libraries have been thoroughly tested and optimized, and they provide a consistent and reliable way to validate your data. By implementing response validation, you can significantly improve the reliability, stability, and security of your applications that interact with external APIs or services. Remember to choose the right tool for the job and follow the best practices to ensure that your validation logic is effective and maintainable.